same thing that we've been doing, but a different way of seeing the world. Okay, we're going to talk about rotational torque and momentum, moment of inertia today. Here's basic key points. Notice I've changed some equations here. You can see how I've done that. Okay, I talked a little bit about moment of inertia there. Here, the big I stands for moment of inertia, an equation, that's that. How we've changed our torque equations. This is where we're going. Okay? Alright. When we started off, if I draw a circle here, I've got a point on the outside, and there's a specific radius r, as the point rotates it around. Okay, Newton's second law says this is true. Problem here, though, is that this A is a linear A, meaning straight line. This guy is going in a circle. Small problem. But, fortunately, some very smart dude said A is equal to the radius times angular acceleration. So to change Newton's formula to make it make sense in rotating objects, all you do is you just plug in that for that. So it ends up becoming this. M-R, that alpha or angular acceleration equation. Okay? That's how we make that one. Next step, okay, we know that torque, okay, we generally think of it as like a wrench turning a bolt, okay, your arm lifting up. We start with this equation. Torque equals this perpendicular force, right? So I could rewrite this as saying force is equal to torque over radius perpendicular. You cool with that?
Yeah.
Okay, what I'm going to do now is set this, since this is what force is equal to, on this side of the equation. Torque over radius perpendicular equals m/r alpha. Right? We're just converting here from a linear world to a rotational world. Okay, I'm just showing you how we do it. With that being said, we know torque, if I multiply radius to both sides, torque then equals m/r squared alpha. Boom, right? Okay, this is for a single point only. Make sure you notice that I said a single point. I'm not talking about a wheel. I'm not talking about a cylinder. I'm actually just talking about one point moving in a circle. Okay? Alright, now with that being said, okay, most of the times there's not just a single point. So when we do this, we have to take into consideration all the points that might be involved. Just like there might be multiple points rotating around this circle. Alright? So what we say then is we say the sum of all the torques is equal to, watch how I write this, the sum of m/r squared for every single point times alpha. Put this in parentheses first. Okay? So, you may also rewrite this as this. The sum of all the torques, this is a very simple way of doing it.
That was smiley face.
Sum up all the masses, times it by the radius squared, times by alpha. Agree this is simpler? All you got to do is add up all the masses and worry about the radius later, okay? This is the one I recommend you use. If you just want to do this for kicks and giggles, okay. Alright, I'm not going to stop you.
I don't believe in kicks and giggles.
I know you don't.
I believe the giggles and kicks.
Alright, now right here, this expression is known as the moment of inertia. And we label this as a capitalized I. Okay, moment of inertia is just pretty much how quickly or slowly something rotates. You all know that some wheels are very hard to rotate, while this, like pen right here, very easy to rotate. Okay, and moment of inertia is just a measure of that. So what we see here is just this way of mathematically showing how hard or how easy it is to spin something. Alright, now when I write this, let me just erase everything. Okay, moment of inertia, again, I said was this. A moment of inertia equals the sum m/r squared for every single point involved. So if I were to write this out longhand, it would be this. m1 r1 squared plus m2 r2 squared plus m3 r3 squared. Do you get my point?
Yes, just keep going on and on.
This is true. Watch this. This is if there's different radiuses. Okay? So if like the points are different positions on the circle, maybe if you have a circle here, one point's here, one point's on the inside, one's really close to the center. This is true for that, because you have different radiuses you need to plug in. If all the points are on the outside, and they all have the exact same radius, use this equation. Sum of the masses times r squared. So you do this. m1 plus m2 plus m3 plus so on, all the masses, times by r squared at the end. That's if the radius is the same.
Hey, these pills, they make your hair grow fast.
It's
Thank
cream
you,
too.
DeAndre.
Yeah.
Alright. So with that being said, let me erase this once. Moment of inertia is like this. If I had a circle, let me see if I can draw this right. This is like if I draw, this is like
You
a
get some cream,
big,
too,
big
from
wheel
Westcott.
spinning versus this.
Rosalind, no, she has one. She had the last year, Mr. Rush one.
Who?
Right? You see these two?
Rosalind.
Oh, wow.
Spinning. This one has a greater I. This one has a smaller I. Can you tell me why? Mathematically.
Oh, I can't hit, but I got a nip.
So if this is greater, they both have the same mass,
Like a blunt.
but why does this have a greater moment of inertia? What's different about it?
It's bigger.
In what way?
Radius?
Because it has like travel like a bigger, it takes longer for it to spin around something.
Yep. You have small radius, big radius. Radius matters. Smaller it is, smaller moment of inertia. Okay? They're equal mass. Okay, with all that being said, let's show you one practice problem, and then I can let you do your thing. And you can stop filming. What?
Put it on DVD and give it to
Oh,
you.
good. I'm
I'm
so
gonna sell it
happy.
to women that got white guy fetishes.
I made a shoulder bounce.
Okay, I do recommend either you get this example written down or you just pay really close attention.
We just film it.
Okay.
And watch it again and again.
The distance between these 2 points is
7.
4 meters.
Oh, 4 meters.
That means distance from here to here is
2 meters.
and here to here is
2 meters.
they're evenly spread apart. Okay, from the
No,
center
they're
of
not.
rotation. Now watch this. On these problems, you've got to figure out where your axis is. These points are rotating around it like this. Okay? Around this axis. Your axis might shift in these problems, so pay close attention to where it ends up. Alright, now we want to figure out, okay, the moment of inertia for the system. Alright, remembering this. Moment of inertia is equal to the sum of the masses times r squared. Alright? For points. This is going to shift tomorrow a little bit. I'm going to show you how it's going to shift tomorrow. But for right now, everything's all happy-dory. So I equals, you're going to sum all this up. Take the first one. And the masses of these points are 5 kilograms and 7 kilograms. So, mass 1 is 5 times its radius of 2 squared plus this whole thing in parentheses.
7.
Okay. 7.0.
Negative 7.
No.
Oh, you got negative 7 over there.
Hmm.
Unless your 7 just ugly.
Oh, it's not negative. All in parentheses, alright? And basically what this ends up being,
20 plus
this is 4. 4 times 5 is what?
20.
4 times 7?
28.
28
Oh, good.
Straight.
equals 48.
Yeah.
What are we trying to say?
That's the moment of inertia for that one. Now watch this. I can shift it. I put the axis over here this time. Shoot out the points. Here's 1 point, and that point is 5 kilograms. This point down here is going to be a 7 kilogram point. Alright, with all that being said, okay, let me just double check. This is 0.5 meters. And whoop, from here to here is 4.5 meters. Okay, this time we're going to have to do the moment of inertia again. When we add them all up, mass 1 is 5. What's the radius for mass 1?
0.5.
20. Oh.
Parentheses. Add it to mass 2.
Wait. Hey.
What's the radius for mass 2?
4.5.
What? Okay, I got a question.
4.5
Why when you
squared.
oh, never mind.
You measure from the axis to where the point is. Okay?
So why when you add the 4.5 and the 0.5? For the
Oh. So that's gonna be
My bad. My bad.
Oh, you
This is
did
4.
add.
So I did add. Whoops. Alright, so it becomes 4.5. This should have been 4 in the first place.
okay.
What?
Alright. Multiply them all together. You get a moment of
You gonna
inertia. Boom, you move on with your life. Okay?
Cool.
Go get.
I'll give you all the change in my pocket if you get this.
Oh, I can get.
You get
Okay.
chimes, or do we get to make it clear now?
496.
No.
Yours?
5.
I know the first one equals 6. I know that gonna be 5. 495.
Keep trying, Harris.
No. Oh,
It gonna be
your mama.
77. Oh snap!
Hold on. You adding it all together, ain't it?
No, he tell me what problem we got.
Correct answer is.
No, I'm
I
saying
know
no.
it It's
Okay.
141.
Wait till tomorrow and do problems.
42, 143. One of them.
Screw you.
I know.
How much change you have in your pocket?
Nothing.
I
Yeah,
probably pushed
that
you
was
the
good.
Clorox ball.